So what is coupling? So we've been talking about software design. In the design concept, this is one of the very, very core concepts, right? What is coupling? Coupling is the measure of the degree of interdependence between the modules. There are a lot of modules, right? For example, payment module and booking module and messaging module. So between the modules, what sort of dependence we have? How much each module is depending on the other module between the modules? A measure of how closely they are connected to the other module. Say module A and module B. Are they tightly connected or they are loosely connected, right? In general, a software should have, if it is a good software, if it's going to be designed nicely, it should have a low coupling. We don't want high dependencies between the modules. Suppose suppose this is called very, very tight coupling. So this is sort of a loose coupling, right? So this module will give an input and this module will give the input and output, right? So the more you remove the dependency, the more you remove the interdependency between the components, between the modules, software is going to function efficiently. A good software will have a low coupling. Once again, the definition of the coupling is a measure of the degree of interdependence between the modules. Here, module means a small component, software component, for example, payment module or messaging module or calculation module. It can be any software functionality. We write it in a small code piece, small function, right? Right. Let's see some example, and then you will understand more. Now come to the cohesion. So now you talked about different modules, different components. These components, different components, should have very less interdependence, right? Dependency should be very less. But when you think of a particular module or particular component, right? So like say we see these are all different components. From there, one component. Within that one component, you may have some variables, you may have some functions, you may have some calculations and everything. Or they're all tightly linked together, right? How how much cohesive they are, right? So basically, cohesion is how they are all related together, right? Cohesion is a measure of the degree to which the elements, whatever the small functions and variables and elements within the module are all functionally related. Are they functionally related? Closely related. It's a degree to which all elements directly towards performing a task, payment. I'm making a payment, right? Through some payment gateway. Are we having the functionalities and related things about only the payment? Anything we have which is not relevant, right? That is what we are looking at it. A good software design will have high cohesion. We wanted high dependencies, a good dependencies, highly related functionality within the module, within the component, right? So cohesion is an ordinal type of a measurement and usually described as high cohesion or low cohesion. Earlier we saw coupling. In coupling, between the modules, between the components, between different components in the software, we want low coupling. We don't want tight coupling. We want loosely coupling, low coupling. Here we want high cohesion. So you will understand more about this when we go through an example. Okay, let's see an example here. Okay, so we are talking about an example of restaurant. Imagine a restaurant. This restaurant is basically automated using software. But let's look at the regular functionality of the restaurant, right? So let's say, imagine the waiter is there and the kitchen are all tightly connected. So waiter has to go all the way, give the inputs to kitchen, and kitchen and waiter are tightly connected. Waiter needs to know how the chef cooks every dish, right? He wants to know everything. Like say, he goes there again, checks that, goes and come back from the kitchen area. If the chef changes the recipe, or the kitchen layout, the waiter workflow breaks, everything will break, right? The waiter directly enters the kitchen and look at the food. He do some mixing and do that, right? So it's going to be tight coupling, right? So basically he has to go all the way, give the instruction, take that. If a customer wants something, right? So it's a very, very bad design, right? Any change in the kitchen forces a change in the waiter operation. He makes some changes, then he has to come again and do that. So it is not modular. It is very, very bad design. Now look at the good design. Low coupling, right? The duty of the waiter is just to take an order from the customer. There's a person sitting at the restaurant at the table. So he just takes the order. He simply send that to a kitchen system. So it just goes to the kitchen, right? Maybe a digital order, or you write something and then pass it on, right? So the person the chef will make all the food and everything gets ready. Then he just puts some bell sound, or say ready signal. Then he goes and then collects it and deliver it at the deliver for the customer, right? So the kitchen can change recipes, tools, process, whatever they want, the kitchen can do, right? Based on the recipe. The waiter does not care as long as the order interface stays same. So this is an order, let it be a burger or pizza or anything, right? So the kitchen and waiter communicate via a clear interface. So these two modules, two components, being like say recipe making and cooking is one module or one component, and getting the order, waiter, get that would be another component. So between these two, there is going to be a very, very less dependency. We just communicate through a small interface, right? So both can evolve independently. He can take any order, he can deal with multiple customers. Waiter one, I mean, yeah, he can go to one customer, he can deal with some requirement, he takes it, and he can go to another customer, he can take the order, he can work independently. And similarly, the chef kitchen also, he can work on his own dishes. He can prepare something like a juice or other things, right? So that's basically low coupling. So the low coupling is a very, very good design concept and design in software architecture and software design. Okay, let's see one more example, then we move on to the same restaurant, how cohesions play a role. So when it comes to coupling in a hospital, let's take an example of a hospital, right? Doctor directly manages the patient billing and pharmacy inventory. Oh my God, right? If the billing system changes its rules, pharmacy updates his doctor process completely breaks. He doesn't know what to do, right? So he is taking everything, right? So doctor is taking care of taking the bill, making the payment, and looking at the pharmacy whether the medicine is available and all. It's too much, right? So that is a very, very bad design. So we don't want so much of dependencies. Just doctor sends a prescription request. Bingo, send the message to pharmacy system. It checks for whether the prescription is available or not. Okay, if it is available, okay, that gets into a billing system, gets automatically notified through a patient ID. Say patient is Venkat. So whatever the Venkat ID just goes to the prescription, and then pharmacy, and then from pharmacy, after it is delivered, it goes to billing system. Then payment is being made. The doctor module doesn't depend on how pharmacy system works, what type of process they follow, what functionality they do. Similarly, billing. But at the end of the day, it's low coupling, right? High flexibility, easy to maintain. So this is one of the core concept of any effective software design. So in general, we're looking for low coupling between the modules. We don't want tightly connected components. We can have connectivity between the component through some small interface. For example, nowadays we are using this RESTful services, HTTP request. You just pass this parameter, right? Patient ID is going to be only passed to the prescription system, and maybe the prescription ID. So the prescription ID will have all the detail, right? Again, it comes to the billing system, doesn't need to know everything, that they need only the amount. So amount has come. So only the small messages are being passed between the modules through an interface, right? So this is coupling. I hope you understand the concept of coupling. Can I get some yes or no from the chat window? Do you understand the concept of coupling before I move on to cohesion? Can you put it in the chat, please? Okay, so thank you. So let's continue. Now go to cohesion. So cohesion is talking about within the component, within the module, right? A particular module, say kitchen module or waiter module. That kitchen should have all the things properly controlled together. Let's look at this. Each department in the restaurant has a specific focus role. Kitchen prepares food. Let's go to the bad design, then comes the good design. Look at this. Imagine one person or one department doing everything. The waiter is taking the order. He goes there and makes that and he cooks it. And then again, he's coming over here, right? So unfocused, right? It's a mixed functionality, right? So the responsibilities are pretty mixed. Maybe chef is coming to waiter area, waiter is coming to chef area, right? So there is nothing like good process in place, right? So it's a lot of workflow is totally confused and very hard to maintain and inefficient, right? So here low cohesion, one unit tries to do too many things, unrelated things, right? So chef supposed to do only cooking, waiter supposed to take the order and greet customer and take the order, take the inputs, right? So when it comes to a good design, right, we will do a specific task, right? Each department is very much focused. Each function, each module, each component takes care of all its work in a complete manner. Kitchen prepares food only. Waiters takes orders and serve food only. Billing customer handle the payment only, right? So each unit will have a focused job. So anything and everything related to waiter will be available in the waiter component, right? So each unit is on one job. All the related information are all put together in the same component. That's called high cohesion, specialization, and clarity of purpose. No mix of responsibilities, no mix of variable, right? So how it is made, how dosa is made, how pizza is made, how this food is made, and all those things is not related. But whatever order, whatever customer says, what we did, what is the table number, and all the details are all tightly focused and tightly controlled in the same module. That's called high cohesion. Okay, so let's go to the hospital. Let's say look at the bad design, low cohesion, right? A single department or a software module doing multiple unrelated tasks. Why pharmacy, you go and prescribe it, and pharmacy also does the billing, pharmacy also does the patient admission, pharmacy also producing a test reporting, is too much of confusion. See, we don't want to put everything in one module, right? That's why you have different components, right? But pharmacy is supposed to do the specific jobs of pharmacy related work, right? The same database table stores medicine information, patient details, so much of confusion, unfocused, error prone, and hard to modify. Any small change is going to affect many things, right? So low cohesion, mixed responsibilities, and harder maintenance. When it comes to high cohesion, a good design of a hospital system, you have a separate doctor department, doctor module, pharmacy module, billing module, lab modules. All the modules or all the components are separately managed, but within that component, all related functionalities are tightly integrated. That's called high cohesion. See, each module class in hospital software corresponds to one specific function, right? So this is basically high cohesion, right? So this is the end of the session today. So next class we will go more on to types of coupling and types of cohesion, right? Say the coupling can be applied for documents, applied for data, applied for many interfaces. So we'll discuss more about the types of coupling and types of cohesion in the next class.